Right, so we're going to deal with critical value method now. So remember when we did critical values, we were looking for these critical regions. So here, a left tail test means that we were going to calculate a T alpha. So this is based on your level of significance. So it's based on that alpha. So it's going to be that boundary where it's going to bind alpha to the left, like we see here. So that's going to be alpha in here, and we're looking for that T alpha. And what we're going to compare to is that the normal T, this is our test statistic. And what we're going to see is my T in this region or not? Is it in the critical region? Because if it's in the critical region, then we reject. So just a reminder, we reject the null hypothesis if T is in critical region. Right tail test. This time alpha is going to be here, so we need the T alpha that splits looks for alpha in the right, so it's in the right tail. Then we have our two tail test that is going to look for a T alpha, but this is a T alpha divided by 2, and we look for negative T alpha divided by 2, because here we have alpha, but in a two tail test, it's split evenly between both tails, so half of it is here and half of it is here. So we need the T value that's going to give me those areas. So we're still making the same assumptions. We have simple random samples. We have sample sizes that are large, meaning they're over 30. Therefore, our population of sample means is going to be approximately normal. Or sorry, our distribution of sample means is approximately normal. So a computer software vendor claims that a new version of their operating system will crash less than 6 times per average on, or per year on average. So that is the claim. So they're saying it should crash less than 6 times less than 6 times a year on average. So what we're dealing with is that our claim is that our mean is going to be less than 6. So that is our alternate hypothesis, because that's always the less than. Meaning the null hypothesis is that it's going to crash 6 times. Because that's when it's always the equality. So a system administrator installs an operating system on a random sample of 41 computers. At the end of the year, the sample mean number of crashes. So what they're getting is, oh no, it's not less than 6. It's more than that. They got a 7.1 with a standard deviation of 6.3. Can we conclude that the vendor's claim is false? So remember, this is the claim. So is the claim false? Or did we just have a really bad time this year? That's really what we want to know here. And we're doing this with a significance level of 0.05. Right. So the situation we have is this. We have a distribution, and since we're looking for a left tail, we're looking for this area here. So we're looking for the critical region. So the critical region is always whatever alpha is. So this case, it's going to be 0.05. So we need the t-score that gives me that area over there, that 0.05. Sorry, I was trying to fix something there. So this is the one value that we're going to need. We also need our test statistic, because we want to see how far is our sample from the claim. So this is going to be our sample mean of 7.1. And then we are going to subtract there we go, the mean from the claim, which is 6. And then we're going to divide by sorry, I lost my number there. 3.6, the standard deviation divided by the square of the sample size, which is 41. So our test statistic is going to be, getting here very quickly, 3.6 divided by the square root of 41. This is going to be 1.9, around to 96. So we want to know, is this going to fall into this critical region here? I think we can already see it's not going to happen. Okay. So we need to go and find our t-table, or we can use our calculator to figure out what t alpha is. Okay, so if we want t alpha, we can use this table here. So we have an area of 5% in the tail. So we're going to use right tail. So remember, we can look right tail. So it's going to show me the 5% up here. And all I have to do is just change my t-square from positive to negative. And we look and we see that with 40 degrees of freedom, because my sample size is 41, that we are going to get that my score here is negative 1.685. Okay. So there's kind of two ways that we can think about how we're looking at this, but like I said, just this way we can look at this and go, okay, well, this is the boundary of my critical region. This is definitely not in the critical region. So here I'm going to fail to reject my null hypothesis. And basically what we're saying here is that we don't have evidence. To support the vendor's claim. So the vendor is claiming that it should crash less than 6 times a year, and we don't have evidence of that at all. Okay. So what we did here is we found that we don't have evidence to support the vendor's claim. We, however, can't necessarily say the vendor is false. We just say we can't support their claim. If we want to show that they're false, we have to do this a little differently. So if instead we want to show that the vendor's claim is false, we got to set this up a little differently, because like I said, we can't just prove something doesn't work. What we could do is we could find more proof that it does work. So we want to show that my alternate hypothesis is correct. So we'd still say null hypothesis is that the mean is going to be 6. So if we want to show that the claim is false, then we would just change the test around and say, okay, well, we think it's going to crash more than 6 times a year. So this is how I showed the vendor is false. So all I showed before with that, I didn't have evidence that the vendor was true. So vendor's claim is false. So not a lot more has changed with this. We still have a sample of 41. We still found that we had a mean of 7.1 and we had sigma was 3.6 and alpha is going to be 0.05. We're looking at this now instead though, where we're going to say that my alpha is over here. This is where 5% is, and we need that t-score. Okay, so we did actually find this with the table, so we're just going to do this again with the calculator. But our test statistic, once again, is going to stay the same as it did last time, meaning my test statistic is still going to be 1.96. We're just going to see if it's in the critical region now. Okay, so let's see what this looks like through the TI-84. All right, so we want to get a t-value here. So we go to second bars and we go to number 3, because this is where we enter in the area. So like I said, we were just doing area to the left just to make it sure it works for everybody's calculator. So the area to the left of my t-score is 0.95. All right, and then we can leave this the rest the same because we don't need a value, we just need a t-score. So if I just want my t-score, I'm going to leave this mean as 0 and sigma is 1. A second, I think I hit the wrong invert normal curve. Yeah, I was supposed to be on number 4. So the area, 0.95. I was gonna say that was a little too much information. So let me show you that again. It was second bars. I accidentally hit 3. 4, invert normal curve. We put in that area. And then we put in our degrees of freedom, which is going to be 40. And so I put in my area to the left, I put in that 9.5. And this is about what we have with the table. This is 1.68. So in this case, when I restructured my hypothesis test, my test statistics in the critical region. So now we reject the null hypothesis. Null hypothesis said that it was going to crash 6 times. We have evidence it crashes more than 6 times. So we have evidence the vendor's claim is false. Like I said, it's just a slight change to the hypothesis test. When my my alternate was that mu was less than 6, we were trying to show the vendor's claim was true. And I couldn't support that. I didn't have evidence to say that it was true. But then I didn't actually have evidence to say the null hypothesis is true, which is that it wasn't less than 6. So I just restructured it to say, okay, well, how about this? We're going to say the vendor's claim is false, which means it crashes more than 6 times. And if I set it up like that, then we see that we have evidence that our vendor's claim is false. So slight tweaks to the hypothesis test can kind of change that what it is you're really trying to claim and what you're really trying to prove. Okay, so one more example. And an industry company claims that the pH level of a nearby river is 6.8. I'm not sure how you measure that. Oh, the pH level is 6.8. Sorry, I don't know what I was reading there. So here, my null hypothesis, because they're saying that their claim is that the pH level of the water is 6.8. Mu is 6.8. That is my claim. So the alternate hypothesis to this is that you randomly select 39 water samples and measure the pH of each. The sample mean and standard deviation are 6.7 and 0.35 respectively, if there's evidence to reject the claim. So to reject the claim, all I'm saying is the pH level is not 6.8. So here, we're going to deal with a two-tail test. So if alpha is 5%, that means half of alpha is in each tail. So this is going to be 0.025 here and 0.025 here. And we want to know what marks these boundaries for us. Because those boundaries are going to be in my critical regions. Okay, so before I do anything, I do need my test statistic. So T is just going to be X bar minus mu divided by S divided by the square root of N. All right, and what we were told is this. We took a sample of 30, or we took 38 water samples, so N is not 38, 39 water samples, it's 39. We found that the mean from all of these was 6.7, and that the standard deviation of those samples was going to be 0.35. So that means T is just going to be 6.7 minus the mean from the hypothesis test, 6.8, divided by S, 0.35, divided by the square root of N, which is going to be 39. Okay, so we're going to have 6.7 minus 6.8 divided by 0.35 divided by the square root of 39 gives me negative 1.78. So we know that's my test statistic. So I just need to know where that test statistic is going to sit. Is it going to be here where I don't reject, or is it going to be in one of my tails? All right. So I'm actually going to do this just from the calculator this time. So I need to figure out what my T alpha divided by 2 is. So once again, we go to second, we go to vars, and we go to number 4, and we put in our area. So I just need to do one of these because remember, T-scores and Z-scores are going to be symmetric when we have the same amount in each tail. So if I just look at 0.025, and then I have 38 degrees of freedom because my sample size is 39, we are going to get, this score is negative 2.02, meaning this one over here is 2.02. So that means my test statistic is going to fall here. It is not in the critical region. We fail to reject the null hypothesis. So since we fail to reject the null hypothesis, that means that we don't have evidence, we don't necessarily have evidence to support our claim, but we don't have evidence to the contrary. We don't have evidence, the claim is wrong. The claim still could be wrong, but we just don't have evidence for it, is really all I can say. Because remember, I'm looking for evidence to support my alternate hypothesis. And if I don't have that, all I can say is I don't have evidence for it. So I don't have evidence to support my null hypothesis. I don't have evidence that the claim is wrong.